Good. Thanks, Jared. Thanks, everyone, for coming. And thanks to the organizers for organizing an awesome event. Really enjoying it. Hope you're all enjoying it as well. So what I'm going to talk today is about Docker. It's a tool that I've really become to love. I think it's a very powerful tool. It's a tool that you can do so much with it. From efficiency to innovation, it really is can change the way you approach security and integrate security. So just about myself, I do stuff. I'm active on the likes of Twitter, try to do streaming. I haven't done much streaming lately, but I'm hoping to get back into that, and things like GitHub and that. So before we begin on Docker, what I want to do is take you through what containerization is, where Docker is, how it differs from something like a virtual machine. So firstly, containerization isn't like a VM. I know I get mocked about this sometimes because I said this before. If you go tell those who are very strong advocates of Docker, and you say Docker is a VM, you'll probably get a strongly worded reply. I put the asterisk there because it's not like a VM, but I'll come to that in a bit. So where containerization, and especially things like Docker, is it relies on the Unix kind of operating system level features. So things like namespaces, process isolation, and file system isolation. So what that means is you can utilize the underlying operating system, but you can have individual isolated instances running on top of that operating system. So a good way is kind of showed in a visual form. So on the left, I have containers, and on the right, I have the VM. If you go look for these diagrams online, it'll probably be slightly different. But what I try to do here is contextualize and make it visually so you can see how they differ. So with containers, you're actually relying on the underlying operating system. So in this case, Linux, Docker can run on things like Windows and macOS. So macOS using that underlying Unix. Windows has to kind of create its own virtualization to create the Linux. But the key bit there is it uses the OS's kernel, so the heart of any Unix system. Whereas a VM uses the hypervisor, which runs on top of that OS, and then it virtualizes the hardware. So when you're comparing the two, basically the Docker instances leverage the underlying operating system, like the core of that, whereas VMs leverage the underlying hardware, virtualized instances of the hardware. So that's kind of where the two differ. Remember, I put a asterisk. It's not a VM, but think of it as a VM. I find this really useful when starting out. I know, as I said, like when you go speak to real advocates about Docker, they're going to say it's not a VM and all that. Or the underlying architecture, the process isolation and that. Yes, it's important, but when you're starting off, it can be really complicated and it makes no difference. Like when you literally starting up a Docker instance and a VM, if you're approaching it from a totally outside black box perspective, you're not going to be able to tell the difference. So my advice is, as you're getting into it, think of it as a VM, but be aware that it's not actually quite a VM. And it's important once you start getting into the realm of it because, as I said, you're leveraging that underlying operating system, so you can then start doing things like writing to the disk, potentially engaging with other processes, potentially. So you can have security differences between a VM, which will be totally isolated, and the container. So where is all this used? Well, I come from a software development background, and I've seen a massive shift. So when we're talking about cloud, we seeing things like containerization is a big shift towards that. you no longer have these big dedicated servers where you run an instance and start it up. You now have all these little, what they call microservices, running in this own little self-isolated clusters. And then you have technologies such as Docker that underline further technologies such as OpenShift and Kubernetes. How many of you have heard of any of these technologies? Awesome. So Kubernetes is a orchestration system. So that's where you can have all these different containers spun up, spun down. It does things like scaling. So as you get more load, it'll scale up and scale down, and all the networking. That's probably a whole thing for another talk. Also, if you do want to find out the more lower level stuff about Docker containers, Starch Press, I forgot the exact name of the book, but they have a Kubernetes book. Go buy that. That goes into, like, the first 6 chapters are just on the whole underlying architecture. So they cover things like the process isolation, network segmentation, and file systems. So if you are interested in that, go read that book. It's really well done. Also, just one more thing on the containerization. Docker is one form. It's probably the most common form, but there are other solutions out there. So if you're not a fan of Docker, there are other options. Docker is probably the most, as I said, most common, so it's probably the most easiest to use and get into. So why would you do all of this? I mean, we've done in the whole past way of doing single servers, spinning them up to work, right? Well, one of the benefits is you can write once and run anywhere. So I'll show you this now. You basically write your containers. And that's really great because now you can have a single piece and deploy it anywhere. Whereas in the past, you probably had a page that you wrote and someone would have to go manually copy and paste that and run those in the different environments. Now you write it once and you can literally have a one-line command that you run wherever you want to deploy this, or even using things like Kubernetes will do it automatically for you. There's version control. So because it's literally a file that you write, you can shove it into something like Git and have a version control. You can have the code reviews, all that stuff done, and the images themselves are version controlled as well. So you can have different versions associated with these different containers. Open source plays a big part in this. So I've now gotten to a point where I'm not really interested in installing open source software unless it has a Docker instance. That's how much of a difference it can make. And part of this is like the open source community allows you to tie all these things together. And you can go see what other people have done as well in terms of Docker and give you ideas. It's simple to run. Really simple. I'll show you some examples. We're talking about deploying multiple services with a one-line command. It can't get simpler than that. Startup. So if you even think of something like a VM where you might have to create a snapshot or whatever, and then you start that VM up, it's actually got to boot the whole operating system and all the services associated with that operating system. Because Docker actually utilizes the underlying operating system, it only needs to start up that application. So you can cut that load time quite significantly. There's no operating system to load up because it's using the kernel. So you can start like a web app server just literally as soon as you run that command. Whereas a VM, it has to do that whole sequence before it even gets to that step. This is really important when you have in especially things like a testing environment where you want a stable state. So with Docker containers, they are ephemeral. There is a caveat where you can mount different volumes, but the container itself is ephemeral. So once you start up, it'll do its thing. If you shut it down, it loses its state. You start up again, it'll be in the exact same state. Now this is great from testing. So you can actually spin something up, test it, bring it down, spin it up, run the test again, and you know that state when you started it will be exactly the same, unless you do things like volume mounting and that kind of thing. It's also stable, so you know what state it's going to start in. And this is really useful, especially if you combine it with things like version control. And it's really simple to learn. I say relatively simple. If you know Linux, you can do Docker. It's really, really easy if you know Linux. It's just learning additional few Docker commands that you put in a Docker file, maybe thinking a little bit differently than you normally would. So especially if you're looking at optimization of the image, you got to approach things slightly different. But the point is you're still literally writing a sequence of Linux commands. And then easy to redeploy. As I said, it's probably part of the simple to run. I've done this before. I changed the service. The hardest part was probably getting a certificate for the service. That's how easy it is. I pointed to the same database, I ran a command, and it just worked. On a totally new separate box, totally different IP address, even a different host name. So I did mention it's available on all those distributions. So Linux, the obvious one. Windows, it does plug well into WSL, so Windows subsystem for Linux. And it works really, really, really well with Visual Studio Code. Like, they all work seamlessly. It's really great. You can actually explore and start and do all sorts of things with the containers. And then macOS as well. Now, there's a warning there. So for Windows and macOS, the only options you have is Docker Desktop. I think Mac might be a bit different, but certainly Windows. If you are using that, it is free for non-commercial use. It's only free for personal use. There was a change, I can't remember how long ago, but it was a few years ago. They did a change. So if you are looking to use it in a work environment, make sure that you read the licensing and get the appropriate license. Linux, fine. Install Docker from the Ubuntu repository, you're good. It's literally the desktop app that you got to worry about. So, that's all about Docker. What does it look like? Well, here's a simple Docker file. So the first one is, the very first line is probably the most common part of all Docker files is you build upon different images. So you can build a layering approach. So you have a base image. In this case, it's Nginx. So we're taking it straight from Nginx. Docker has a repository called Docker Hub, and that's the public repository that Docker by default points to. You can have your own repositories. So you can host things in like AWS that have, GitHub has their own one. You can even host your own self-hosted repository using something like Harbor. Harbor is an open source Docker server that you can run. You eventually get to a top level, which is like your base OS type thing. So you can have Ubuntu. Alpine is really common for Docker images because it's very, very lightweight. It kind of cuts out a lot of things. Be careful though, because it cuts out a lot of things, you may find that you actually spend more time trying to get things to work and install additional software rather than just using something like Ubuntu. And really the differences between the size of them is not that much. You're talking about megabytes, not gigabytes. So just keep that in mind. So this is taken from the official F5 Docker Hub repository. The official F5 Nginx image from the Docker Hub repository, and we're just adding. We're adding content. So we're basically taking the directory and put it in that user share Nginx HTML, which is basically taking your static HTML and putting in the Nginx repository, and that will serve it. And that's it to start a web server. Simple as that. One line command. Well, actually, I lied. There's maybe 2 or 3 commands. You got to build it and then run it. This is a bit more advanced one. And this is kind of leading into where you can start using Docker for security purposes. So this was from a CVE that I was researching. It's the it was what was it? I forgot which one it was. I think this was one of the libraries that you could do things like RCE and that on. And using Docker is a great way because you can quickly build up a simple test application, spin it up, and you get all those ephemeral things. So if I break it, stop it, restart it, and you get a clean, fresh install. So if you are interested in more, there's the GitHub repository at the bottom. You can go download it. It's got all the instructions and all of that. But this is just giving you an example of a more advanced Docker file. So there you've got Ubuntu, it's the base one, and then you're doing basically a bunch of I keep on thinking this has a laser on it. Didn't bring my own pointer. So yeah, the next few lines is like installing from out, and then actually installing the vulnerable application, and then running the exploit against that. So that was the Docker file. So the way you do it is you define a Docker file that defines your image. You then need to build that Docker file so it actually creates the image, and then you will run it. So that first command at the top is building the image from a Docker file. So if you don't specify the Docker file, it will just look for literally a file called Docker file with a capital D, or you can actually specify it using the argument. The -t is given a template so you can give it a name. And then when you run it, you actually specify the template that you want to run, and you can give that container a name. And then there's a few other arguments such as the -p, which is associating the port on your host to the port that's actually running in the container. And that's how you can access those things within that container. The way Docker works is, as I mentioned, you have images. So that's kind of like the blueprint. And then when you run it, it will actually execute those images and put them into practice. It also does layering. So you get, I wouldn't say performance, but this enhancements. So if it finds two layers are the same, it's not going to re-download it. And this is where it can go down a whole road of optimization, reusing layers and all sorts of things. Probably outside of the scope of this. Stuck that in there because, you're going to mention solutions. The point about this is, obviously, this is awesome technology, but there's going to be cases where it's probably not going to be useful. So be wary, use it where you see it appropriate. And as I mentioned at the beginning, Kubernetes is a really good technology. Kubernetes started by Google, and it's evolved and become probably something that's used widely. I don't know the exact statistics, but it's certainly becoming something that I see many organizations using more and more. Docker Compose. This is an awesome tool. This is probably something you'll use more from a security point of view. So Kubernetes is a very big monolithic thing. This is really if you want to run big services and that for organization, like production services. Docker Compose is like a lot. I like to think of it as a poor man's solution to Kubernetes. It really simplifies things down so you can run it on a box. It is awesome. And it's relatively simple as well. So this here is an example. I can show you in a bit, but I've got another example I'll show you live and running. But there's another example if you want to go look at that guess. But in there, I have dependency track, which is an open source solution. It requires an API server, a web server, and a database. Using one single file or run all of those, when you want to run it, one line, one command. So those are like the background of Docker. What can you actually use it from a security point of view? Well, the first is a demonstration. So I have some examples at the end. See with time. Hopefully that should be good. But it's a really, really useful tool. So if you're thinking things like cross-site scripting or SQL injection, and you want your developers to experience that, write a little application, shove that in there, put in a Docker file, and give them to run it. And then they can do whatever they want to it. And you also know they're protected. They're not going to destroy your web app or whatever, because it's all in isolation. And if they break it, stop it, restart it. It's an awesome tool. Another good way of using it it kind of relates to another example, is if you find a vulnerable web app, so using a third-party service and there's a vulnerability in there and they have a Docker instance, you can use that to then do a demonstration to the team to show why we need to worry about this, or here's an example of where this vulnerability can be used by an attacker. Next thing is tooling. So this is really, 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 really helpful. So I mentioned things like dependency track. So you can spin up tooling really quickly. And this is what I also mentioned. When I look at open source stuff now, my first port of call is, do they have Docker? Do they support Docker Compose? It really, really makes it so much simpler. Like, you're talking about one line command. I know I say that a lot, but I'll hopefully show you. And then it just makes the management and all of that so much simpler. If you're talking like dependency track, if I had to go and install it, I have to install the database, the web app, the application server, and then if I want to change the version, I have to go and like redeploy it, reconfigure it. Docker Compose, you just change the version number and restart it, you're done. Another part you can do is, again, if you have people like your development teams or other teams that are not security focused, you can start abstracting security tools from them. So instead of them having to have all these tools like Nmap installed or SSL scan installed and this, you just go use this Docker file, run this command, one line, and they can run the scan themselves. So, and it goes for the same as if you have your own internal scripts or something like that. You can kind of build it into a nice wrapper for them. Similarly with DevSecOps. So if you have like your CI/CD pipelines and that, this is really, really, really helpful. So some of the things like GitHub and GitLab, they have GitHub is called GitHub Actions, and GitLab is called GitLab Runners, where you can actually have these Docker images running when a commit's done. So you can do things like your code scanning, your SA scanning, all automated, get the results in, and it's all part of that continuous pipeline and scanning. And then the last one that I have here is research. So I already kind of pointed to that proof of concept what I had. So you can use it to research vulnerabilities out there, and especially if there's a vulnerability in a software program and you want to find out if you're actually vulnerable to that or what the vulnerability means, you go look for the version. You can spin up an instance really quickly and start playing around and essentially hacking it. That's what we enjoy doing, right? And yeah, it just makes life so much easier. So I do have time. So I want to show you now some examples. So one of the things I have running here, let's get the right screen, let's get up quickly. So this one here is an example where we have a web app running. So this is just a static page, and pull this across. There we go. So that static one is the simple HTTP server, and there's a Docker file with that content and pulls that in. And then there's a Docker file there. I'm not going to go into too much detail because of time. This is all available on a GitHub repository that I'll give the link to at the end of this. So if you want to look further, you can go look at that. In terms of the OpenCTR one, this is like, as you can see here, this is all the Docker services that it runs. This looks quite a bit advanced, but it's actually not once you understand the syntax. That's really what it is. And it's spinning up a load of services. And in fact, I don't know if you can see if it's resized it. Yeah, there we go. You can see all those services starting up just from Docker Compose up, one command. And if we have a look, this is the service running here. I forgot the login details. I know one of them is very...
Love the password.
Yeah, super secure password. Obviously change the password when you do run in a production environment.
I'll never see it.
There we go. That's running. This tool, by the way, OpenCTR is awesome. Have a chance to go look at it. It's really, really cool tool. But yeah, that's that OpenCTR running. So behind it's got MQ, Elasticsearch, a web app, and you start all of that up with one line command. In order for you to do that manually, it'd probably take a day, maybe, if not. And then you got to configure all the connectors to connect to it. Again, one line command. What's the other one there? So the other one that I want to show you is this trace one. So sometimes getting trace can be really difficult. So one of the things I've done in my work is start building up like this toolkit for developers where, hey, how do we know we fixed trace? Well, you can now spin this up and give them an example, and then they can know how to fix it. So in this case, I'm not going to run. See if we can try run it. Sorry, it's very difficult trying to do two screens at once. But what I won't do is show you that trace one, but I'll show you this Docker, this test SSL. So this test SSL is a security tool that you can run and check your HTTPS TLS configuration for the site. And what I've done here is put in a Docker file, and if we run this again, something like Google.com, hopefully I spelled that right, it will now run this tool against Google.com. So if you imagine you give this to your developers, I'm not connected to the internet, that's why. That would help. But you get the idea of it. It prints out from the tool. So what you would do is give this to your developers. They run that one-line command. They don't have to install anything as long as they have Docker installed, and they can suddenly run it and test their server that they had to go and fix and patch, or if they're even worried about the server being vulnerable. Really, the limitations are just what you think of and how creative you really get with that. So, as I said, it is all available online, so it'll probably be easier if you want to have a look at it without me trying to multitask, which I'm terrible at. But yeah, I have the link. I thought I had it in the slide, but it got lost somewhere. But if you look for me, Sean Ratzek, on GitHub, you can find the repository there, or just give me a shout. Even on Twitter. Any questions? I think there's one. Tom? No? Cool. All right.